My name's James Saul, a solutions architect with AWS. I actually joined AWS here in Singapore about 4 years ago, but I've been back in the UK for a couple of years now, so it's a real privilege and to be back out here and presenting to you guys. First of all, I really want to talk about some of the reasons why customers are choosing to run a Microsoft workload or Microsoft Workloads on AWS. And also, there's so many different products that actually run on top of Microsoft. And Microsoft in turn runs on AWS. But what I'm going to focus on here is the actual Microsoft products themselves. Then I'm going to cover one of my favorite topics, which is developing .NET, PowerShell on AWS. And like any presentation that covers Microsoft, I'm going to dive a little bit into licensing, so it's going to be a pretty important consideration for you. And then at the end, I've sort of sneakily put in, I want to draw your attention to a service, relatively new service at AWS, our service catalog. And it can help you solve that conundrum, that puzzle that is, how do I, on one hand, have agility, self-service, autonomy, microservices, DevOps, widespread across my organization, whilst at the same time having governance and control and standards. So the reasons actually for customers running their Microsoft workloads on AWS is very similar actually to all the other workloads that migrate to AWS. AWS has been delivering a hyperscaled commercial cloud for over a decade. And that amounts to an extraordinary amount of experience. You can go online and research that 10-year track record, and hopefully you will discover, our real focus on security, our relentless pace of innovation, and continuously lowering prices. Now, initially, customers coming to AWS, have maybe been driven by the low cost of cloud, driven by the vast economies of scale. But actually, increasingly, we're hearing that what's really making a difference is that it's the agility, and you heard that several times throughout today. So the low cost affects the bottom line, right? You can drive big costs out of your business. But actually, agility allows you, it really defines what your business does and what you can do in your business. And it's that agility that affects the top line. And that can actually, and customers are having a more impact at that level. Then there's performance. There's two aspects to this. There's one which is just straight line performance. You're coming to AWS because you want access to the very latest Intel CPUs, maybe even the custom Intel CPUs made for AWS. But actually, I like to think about the appropriate performance. Whether you're choosing a little T2 Nano with its small amount of CPU that can burst, or whether you're thinking about the upcoming X1 with 100 vCPUs and 2 terabytes of RAM, maybe to run some of those very intense high memory workloads that the industry is moving towards. Or one of the 30 plus different instance types in between, optimized for all the different types of workloads. And you'll want to be able to deploy infrastructure probably anywhere in the world at any point in time, right? So it's not uncommon for organizations to have a global footprint, or if they're actually just a small organization that wants to go global, they want to be able to have that consistent environment anywhere in the world. Currently we have 12 regions geographically, including 33 availability zones. Each availability zone, Mark referred to it as a logical data center. In fact, it may be one to 6 data centers. And each one of those data centers may have anywhere between 50 and 80,000 servers, and those data centers interconnected at more than 100 terabits a second. And throughout the next year, we're hoping to bring online 5 new regions, comprising another 11 availability zones. But cloud actually would be of limited use if there wasn't a really strong ecosystem around that. You want to be able to move and take those workloads into the cloud and find all of the products and services that you need. So having a very strong partner ecosystem and a good, strong marketplace here, we say 2,500 plus products in the marketplace, that like an app store, you can just go along and with a click of a button deploy the software that you need to get your job done. Security. Now, whether you're building a hobby application or whether you're actually migrating your entire enterprise to AWS, you'll actually exploit the same consistent global platform, which is the superset of these and more security and compliance features and capabilities. And I really encourage you, if you're on this journey, to follow the links that I'm leaving in the presentation here, because that will help you, I hope, conclude that, like other companies like Capital One Bank, mentioned in the keynote, or even a recent IDC report that actually says you can be more secure in the cloud. Reliability, a key cornerstone of anyone hoping to pin their business on a supplier. So it turns out that actually building highly available, resilient systems in the cloud actually doesn't really take any additional effort. It's a default position, if you will. So whether you want to create a load-balanced environment across those multiple data centers, or you want a managed relational database that automatically backs up, automatically fails over in the event of a problem, these are things that you actually really have to have, there's no extra effort in order to get that. And whether you actually want to use things like auto-scaling, which has this additional property of auto-healing, that can also default you to a highly reliable position. High performance. So Windows can exploit all the high-performance instance types on AWS, whether that be the upcoming X1 I talked about there, or whether it is Windows in its HPC variant. And you can also take advantage of all the high-performance networking, and whether that be VPC's enhanced networking, which is essentially single-root I/O virtualization for very consistent, low-latency, high packets per second networking. But hopefully you get the point here that generally speaking, migrating your Microsoft workloads onto AWS is that it's very much a first-class citizen, and all the reasons that everyone else has for migrating their workloads to AWS equally apply to your Microsoft workloads. I think we're out of sync a little bit there with the slides. So what Microsoft workloads will run on AWS? Can we sync up the slides, please? Thank you, thanks. And it turns out that every imaginable use case is essentially is covered. So what I'm going to do here is I'm actually going to pick on a couple of the case studies that you'll find here, and there's actually a special link at the bottom specifically towards Windows-based case studies. So GPT, a property group out of Australia, essentially migrated almost their entire data center to the AWS cloud. And 70% of it they found was a straightforward lift and shift. Some applications and systems required some intervention, so they found that it took a day to move their Active Directory over, and it took a weekend to reconfigure and bring SAP over. And now nearly all of their core systems are running on AWS. So that's everything from their SAP ECC, Active Directory, SQL, SharePoint, and so forth. Then you've got the giants like GE, and you heard about their oil and gas division this morning, migrating more than 9,000 workloads over to AWS. Many of those will be Windows-based, and they're essentially reducing their data center footprint by 30 data centers down to 4. And actually, whilst they're doing that, they're already seeing a TCO reduction of over 50%. This exec view of the IT landscape hopefully demonstrates that AWS caters for almost all of of IT today. So that includes at the core foundational levels, we have the network infrastructure and the security, giving you deep expressivity for networking, whether it be firewalling, encryption, access control, and so forth. And then on top of that, there are things like support for the DevOps model. So microservices, continuous deployment, so where you want to store your code, automate and orchestrate your continuous build and continuous deployment services, and actually deploy into managed IIS and .NET environments such as Elastic Beanstalk, which again has been highlighted throughout the day. Moving from there, there's the business applications and corporate applications such as SharePoint, Exchange, SAP, HR, CRM, all integrated with Active Directory and System Center. And you'll find online a lot of these embodied in reference templates. And then we've got end-user computing catered for with Amazon Workspaces, so that your employees and sales task force, etc., can actually have their Windows desktop via a variety of tablets and mobile devices and PCs and MacBooks and so forth. And also there's a solution for application management that offers a fast, flexible, and secure way for you to package, deploy, and update your desktop applications. So ultimately, there are very few reasons and very few workloads that would actually not migrate to the cloud. But let's drill into some of the Microsoft products themselves. So up here, you'll see some of the most instantly recognizable Microsoft products that can all be deployed and licensed on AWS. And hopefully, like GPT, you'll find that you can do so with lower cost, better security, and at least same, if not better, performance. Now that could be for a variety of reasons, such as right sizing, which is the notion of actually taking real measurements of your infrastructure and actually then sizing the instances and the machines to actually match the requirement. So bye-bye over, under-provisioning and over-provisioning, actually being right-sized. Like I said earlier, being able to be highly available and resilient by default. It's no extra effort. Multiple data centers, multiple availability zones. Easier to meet with compliance and regulation by leveraging that platform I described earlier of security and compliance. Or it could be unexpected advantages, like Mark pointed out earlier. Immediate and unbounded, unconstrained access to test environments. So no longer being blocked, waiting for access to infrastructure so that you can test and rehearse upgrades, patches, or new versions of software. As soon as you need it, you have access to it, and when you're done with it, you put it away. That can make you a more agile organization and a more robust organization. No more excuses for skipping test. So let's drill into SharePoint. What you can see here is a sort of standard reference architecture. We've got multiple availability zones. We've got public subnets. We've got private subnets. But what's more interesting about this is that we're reducing the scope of effort that you have to put into this, because you'll notice that many of these components are now managed components, right? So you've got managed firewalling in AWS EC2 security groups. There's managed Active Directory that Mark covered previously. You've got managed network address translation, managed load balancing, managed desktops, which actually means all you have left to focus on is SharePoint. And even then, that's made simpler because you've got access to things like EBS, our block storage solution, with built-in encryption. Or you can employ and integrate and use AWS CloudTrail for auditing all changes to your infrastructure, and AWS Config, so you can observe changes in your infrastructure, so that you can actually make sure that you're always remaining secure and compliant. But you don't need to stop there. Bring in all of the other services and products that you need. So Exchange, link server, remote desktop gateway, SQL Server, direct access. And you'll find all of these detailed in Quick Start, which are detailed, I've provided you a link there. They are essentially detailed implementation guides with accompanying templates. So with a click of a button, you can rapidly deploy fully functional software following our best practices. But let's go beyond there. What you'll want to do is, once you're migrating and you're comfortable, is you'll start to want to optimize for running in the cloud. And I've highlighted some partners here, for example. So SharePoint and SQL Server, we all know, are very competent and excellent products. But you probably would think there's a poor use of those technologies to be putting many, many terabytes of blob content into those stores. Now, they can do it, right? But what you'll end up doing is provisioning lots of block storage on high-performance SSD, perhaps, and that would be a poor choice when actually we can extract all of those blobs from SharePoint using some of these products and put it into a blob store, Amazon S3. And the result is a much lower cost of operating that SharePoint environment, higher performance because it's having to manage less blob content, and ultimately everyone's a winner. But let's drill into SQL Server. This is a reference architecture, and what you'll see is that Windows Server failover clusters and always-on availability groups are underpinning many of today's enterprise class and mission-critical SharePoint systems, .NET applications, and so forth. So in this reference model, you can see that we're using multiple availability zones, and we're in fact also using synchronous commit in this availability group, which is perfectly reasonable, because the latency between these availability zones is in the region of 1 to 2 milliseconds, depending on where you're deploying in the world, which is very straightforward to do, and there are reference architectures and templates to help you get deployed. Now, Dr. Werner Vogel's mentioned in the keynote, actually, that when you're migrating to the cloud, that could actually just take days, or it could take weeks, months, or maybe actually take years, depending on what constraints you're having to work through. So it's quite possible that you'll be following Mark's advice and setting up a direct connect or a VPN to establish connectivity between your cloud and your off-cloud resources. And it's quite reasonable, therefore, to extend your availability groups between those different infrastructures. And it might be here, as we're showing, for different use cases, such as reporting, but it also might be part of your continuity planning, business continuity. A customer I had was working with last year actually referred to their migration project as DC3. Imaginative, they had DC1, they had DC2, and the cloud was DC3. But I think it gives you some insight into, in their topology for their enterprise, exactly where AWS stood. It was actually very much a key and integral part. And by establishing this strong connectivity between these infrastructures, it made it very simple, very straightforward, and transparent in order to execute that long-term migration. Because things like dependencies and relationships, such as trust relationships between Active Directories, could span those reliable and highly available links. You might also want to take advantage of the Amazon Relational Data Services for SQL Server. As a managed service, it's going to look after things like failover, patching, backup, recovery. And this is very empowering because it actually allows you to manage a great number of SQL servers with very, very impressive server to admin ratios, which is something that some people have essentially a KPI to drive. These relational databases could be AD integrated. So in this picture here, you can see that it's integrated to the managed Active Directory, which has a trust relationship, possibly over a VPN or direct connect to Active Directory on premises. And that allows you to do things like simplified management and also to have your .NET applications use a trusted connection. So no need to put passwords into your .NET code running in ASP.NET, for example. And so what I wanted to do here was introduce Simple Systems Manager. It doesn't necessarily fit within this section, but for the sake of a good sort of segue, I just didn't want to omit this because I think you'll find it very useful. So once you move beyond your sort of proof of concept and you're moving beyond just having a single server and you'll want to have to manage a large fleet of Windows machines. And in order to do that, you want simple mechanisms for managing that fleet. So this allows you, without granting host access to all of those individual machines, you can actually automate these repetitive tasks through the console. And what you can see here is a screenshot of the console where someone's highlighting a list of machines, and then they're going to either issue a command such as to instruct them all to join Active Directory, or to install a MSI package, run some PowerShell scripts, and all of this. And all of these actions are going to be controlled by identity and access management, consistent with the rest of your infrastructure, and also it'll all be logged into CloudTrail, so you can see exactly what happened and when it happened. Which brings us to development. So AWS, everything sits with API access, okay? Now, it's rare for people to work directly at that level. So we provide SDKs that wrap up those APIs, and those SDKs are supported on all of the core Microsoft execution environments, and you can see those across the bottom there. And then we've got some more abstract tools that are beyond it. Maybe you want to be able to import your virtual machines. So we've got tools to help you import your virtual machines from off-cloud to in the cloud. Or even higher up the stack, we might have things like an ASP.NET session state provider. One of the things you want for your session state is for it to be durable and high performance and scalable. And one way to do that is to store it inside DynamoDB, our NoSQL store. So ASP.NET has a provider model, so you can just plug in our session state provider and take advantage of DynamoDB. But of course, most of development actually takes place inside the Visual Studio IDE. And in order to support that model, we have a toolkit for Visual Studio that plugs in and provides a toolkit such as the one I'm showing on the left-hand side there, which shows how I can now browse most of the resources I have in AWS. So I can see my EC2 resources, I can see my relational databases, I can see my DynamoDB tables. Maybe I want to double-click on those DynamoDB tables and see the data inside them, edit that data, and then continue coding and testing. On the right-hand side here, I'm showing that I've started by start a new project. I've picked an AWS template, and I've built my application. And then what I've done is I've gone right-click straight from within my IDE, and I've said publish and deploy into AWS. And what I can do there is I can either deploy directly to EC2 machines, or I can actually say, please target Elastic Beanstalk, which is that managed IIS.NET environment. How about I want to incorporate those cloud platform services into my application? So all I have to do is go to the Visual Studio Object Explorer and find the objects and services that I want to interact with. And this is how simple the code might look. And here, all I'm doing is storing a file in the blob store. So I think you'll find that it's actually all very straightforward to consume and take advantage of the AWS Cloud Platform services. It's not just about deploying Windows and everything just on a virtual machine. You should be able to take advantage easily of the platform services. But we live in the age of DevOps and microservices, and that encourages us to be writing fault-tolerant systems that are highly cohesive, loosely coupled, and asynchronous. And one of the things that helps us be asynchronous is queuing systems, such as Simple Queuing Service. And this is how straightforward the code is to queue and then dequeue messages on that platform. And DevOps is ultimately a movement that encourages small teams with a lot of responsibility. And to do so, they effectively have to really exploit and leverage the platform. Those teams don't have time or capacity for configuring, monitoring, patching, a load-balanced fleet of IIS machines, and nor do they have time and capacity for the infrastructure to store their code and to manage and orchestrate their build processes and to deploy or maybe undeploy failed deployments. They should be concentrating on building useful, engaging, robust applications. So developers can use code commit to store their code. They can use code pipeline to do the orchestration of the build pipelines. And they can use code deploy to take that code and deploy into a managed IIS and .NET platform, such as AWS Elastic Beanstalk. And you can also get access to all of this through PowerShell commandlets. When I put this deck together, there were 1,821 different commandlets to help you work across the variety of different services. I checked yesterday, and that's gone up to 1,831. I don't think we're going to be slowing down anytime soon in the number of services and capabilities we want to put in your hands. Which brings us to licensing. So, one of the, all of the options for Windows Server and SQL Server and the full range of Microsoft applications is available on the AWS platform. And the first column really only applies to Windows Server and SQL Server. AWS is a very large reseller of these applications, but we don't actually sell other Microsoft products within our EC2 instances. So the first column, you're going to launch machines, and you're going to be fully licensed for Windows or SQL Server, depending on the instance type you launch. And we're going to look after the licensing, and you will pay for the license in the cost of the instance hour. Very straightforward to get started. But if you've already made significant investments in those Microsoft licenses, you'll want to bring them over onto the platform. And you can do so with bring your own licensing. And I'm going to cover in a moment the dedicated hosts, which can significantly help you bring your own licenses without the need for software assurance. And then on the far right-hand side, if you want to deploy into a multi-tenant environment and you have got software assurance and license mobility, then that's how you can bring those licenses onto the platform too. So recently, we introduced dedicated hosts, and the big advantage they bring is that they actually expose the underlying cores and sockets of the host machine, and they give you host targeting and affinity controls to allow you to actually ensure that the virtual machines you're running run on those cores and sockets. And that allows you to comply with your licensing requirements, and especially sort of the 90-day sort of affinity requirements, or where licenses are socket and CPU bound. So you can use this capability to help you. Also, all of the machine launches, machine restarts, you can ensure that whenever those events happen, those machines always go onto that dedicated host. And all of those actions are also recorded in AWS config, and you can use AWS config as a data source to help with your license reporting. MSDN is, there's no technical reason why software available under your MSDN subscription cannot work on Amazon EC2. I'm just going to sort of quote you something from the volume license product use from 2014 that states, you may install and use permitted copies of the software on servers and other devices that are under the day-to-day management and control of third parties, such as ourselves, provided all such servers and other devices are and remain fully dedicated to your use. And so you can use dedicated instances to help you achieve that goal. Supportability is another big question customers have. So AWS is a member of the Microsoft Partner Network. We resell software via the SPLA, the SPLA. We're a gold certified partner with active Premier support agreement with Microsoft. So if you have an issue, you call our support, and if the issue extends beyond AWS technologies, we will engage with Microsoft and we will provide a coordinated response for you to support you running your Microsoft workloads on AWS. Which brings us to that interesting conundrum I placed at the start of this presentation, which is, if we're doing a mass migration and we're moving a large organization into the cloud, and we heard a lot throughout today about agility. So what we want to achieve is we want to essentially empower all of the teams and organizations, maybe all around the world, at scale, with this magical agility superpower so that we can compete and be the most effective in our marketplace and achieve those business outcomes Mark talked about earlier. So how do we do that whilst also having governance and control and standards and be confident that we can comply with either our regulator or our own internal standards? And that's when we introduce the AWS Service Catalog. So on the one hand, we want the agility and self-service and the time to market that everyone actually wants, and that's what everyone in your organization will have heard about, and that's what they want to benefit from. And at the same time, your administrators want to empower everyone to be that way. Ultimately, we've switched slides here. What can happen is that if you don't have this service catalog I'm talking about, the administrators are going to be bogged down. They're going to have thousands of requests coming in. Like Mark said earlier about this marketing team saying, please, can you deploy this infrastructure very quickly for me? I've got this marketing launch coming up. You'll end up with a massive queue, and probably most of the times either being late or saying no, and you have to prioritize. So actually you want to disintermediate. You want this self-service. Users, they want to be unconstrained, except maybe by their budgets and their controls. You want to have those standards. You want to meet compliance. Compliance is something you genuinely want, right? And you also want to reduce that cognitive load. If you're going to bring all of this AWS technology into your organization, then one of the things you want to do is lower that barrier to entry. You want to reduce that cognitive load. You don't actually want to have to train every single person in your organization with all the minutiae of AWS. You want to empower them, enable them, and create these abstractions. So these CloudFormation templates are a very good example of that Mark introduced previously. And you also want to be able to tag everything so that you can actually have full kind of reporting capabilities on what's been launched, and also be able to sort of have clarity and transparency in sort of that cross-charging, show-back, charge-back. So let me talk you through very quickly what that service catalog would look like. So on the far left-hand side, what we have is essentially a cloud center of excellence. We have maybe a relatively small team initially of people with deep skills in AWS and IT. And what they're going to do is they're going to embody best practices around from their organization and from the industry. And they're going to embody those in those CloudFormation templates that you saw earlier. And those CloudFormation templates could be anything from launching a single virtual machine, with Windows and maybe SQL Server on, all the way to an entire virtual data center. Again, something Mark introduced earlier with managed Active Directory, maybe SharePoint, and Exchange. It could be the full thing. Basically, an entire enterprise in a template or a set of templates. These can then be published into a service catalog. Okay? At which point they become discoverable by end users. So end users can go to the service catalog and essentially list and search for products that they need, knowing that they've been written and authored by experts. All they then have to do, if they've been given permissions and granted permissions in their part of the organization, they can launch those stacks, as you saw previously. Those stacks will be launched, and then they will be able to log all of that information into CloudTrail, so there's a full audit of what's just happened. And whenever changes are made to those environments, that goes out into AWS config, so the administrators and infrastructure experts can actually continually track changes and see if there's any deviation from their standards and therefore continue to meet with compliance. And if what happens is there's a new version, or there are upgrades, or best practices move on, then again, we go back around the loop. The administrators and the Cloud Center of Excellence can then create new standards, new capabilities, publish them into that service catalog, and now people can see the new versions. And then they can actually tell the CloudFormation template to update itself and deploy those changes. So at this point, you've got an organization that is self-service and has that agility. And with that, I come to an end.